All right, here we go. Chapter 16. So we only have, I think, two sections, 2 or 3. Can't remember off the top of my head. But chapter 16, compound inequalities. So real quick, we're just going to review the inequality symbols before we get started. So inequality symbols are less than or greater than, less than or equal to, greater than or equal to. And when you're graphing, remember use parentheses for the less than or greater thans. And for the less than or equal to or greater than or equal to, we go ahead and use brackets. Okay? Today, we're going to talk about compound inequalities. All right? So compound inequalities are, let's see how I can say this here. Two inequalities that are joined with the words and or. All right, so you can use either word. Okay? So you're going to have two inequalities that are combined with one of those two words that are listed. Now, the first one that we're going to specifically look at is going to be the and statement. Okay? So the and statement denotes an intersection of two sets. So let's review. Oh, that's a horrible way I wrote the notes. There we go. So let's review what are sets. So a set is a collection of objects with a common characteristic, something in common. Like all those little numbers have something in common. Now, if you recall, when we learned the definition of a function, all right, a function, remember, is it's a rule or a relation that relates the set A of the domain to set B in the range. Do you remember doing that? Okay. So the common characteristic there were all the x values of points, and the other set was all the y values of another point. So when I see this definition, the and statement denotes an intersection. Visually, what that looks like is this. This is called a Venn diagram. Some of us may have heard it, some of us may have not. Okay? So it's called a Venn diagram. All right, now in a Venn diagram, we have two sets. The first circle, I'm going to call set A. And the second circle, I'm going to go ahead and call set B. Now, the only thing I'm going to do here to just kind of really illustrate this is I'm going to go ahead and just shade. So set A, I'm just going to shade it in this yellow highlighter. And set B, I'll shade in the blue one. Okay, there we go. And what's really important here is that overlap in the middle. That overlap is going to be the intersection of sets A and B. And we give it a special symbol. It's an upside down U. It looks like an upside down U. Okay? And that's called the intersection. So I can label that right in the middle. And the way that we read that is just A intersects B. So what we're looking for here when we are examining two inequalities combined by the word and is we're looking for the values that will satisfy both inequalities. Okay? So let's look at a pretty simple example here. Okay? We're going to solve 3x is less than or equal to 5 and 9x is greater than or equal to 27. Okay? So the way that we approach this is actually very simple. We're going to do two separate problems. We're going to graph them. And then we're going to combine the graphs on top of each other. We're just going to take one and move it right on top of the other. So let me show you what that means. So for the first one, 3x is less than or equal to 5. I divide both sides by 3. And that gives me x is less than or equal to 5. So what I'm going to do is over here on the right-hand side, I'm going to go ahead and graph that inequality. Now, I'm not too particular about where the 5 is. I know it's to the right of 0, so right in the middle I just put a 0. And then off to the right-hand side, I'll put a 5. Now, the inequality symbol tells me which direction to shade. So I'm going to shade to the left here, okay? I use a bracket. And I'll just shade to the left. All right, so there's my first inequality. Now, the second inequality is going to be 9x is greater than or equal to 27. So I will divide both sides by 9 to give me x is greater than or equal to 3. So I will draw another inequality. Now, with this, I do care a little bit about the spacing. I know 3 is smaller than 5, so I just make sure that when I come directly underneath, everything's nice and lined up, it's nice and organized, and the 3 just becomes before the 5. So I want values of x that are larger than 3, and I can use a bracket here, because it's greater than or equal to. And now my next move is to take these two graphs that I have and just graph them on top of each other, okay? And the reason why I want to do that is because I'm looking for the intersection of these two. Remember, and here's how we always write the final line. Underneath, if you want, you're going to write some squiggly braces. So I hope you remember doing this. This is called set builder notation. And what you write on the right-hand side are going to be the two conditions. X must be less than or equal to 5, and x must be greater than or equal to 3. So x is less than or equal to 5, and x is greater than 3. Now, to graph this, like I said, you're going to come directly underneath, and you're going to notice here, So just give me 1 second here, okay? Just watch for a second. There's my x is greater than 3. Here's my x is less than 5. And if you notice, right here in the middle, that's where those two functions, or that's where those two inequalities overlapped. That is going to be the intersection of these two inequalities. Now, that is what I'm looking for when I have an and statement. I need values of x that satisfy both inequalities. That will only occur between 3 and 5. And you are allowed to include 3 and 5 in your solutions because it's less than or greater than, sorry, I forgot that right there. Because it's less than or equal to and greater than or equal to. So, to check yourself, all you have to do is select a number that is inside of the shaded region. And it has to satisfy both. Hold on. Oh, we almost had a catastrophe there. Okay. So it has to satisfy both. So what number's in between 3 and 5? Now, please, I love my other class, but I gave them that question, and it took them like 5 minutes to think of a number between 3 and 5. Thank you, Abigail. 4. So what I'm going to do is I'm going to come up into my original equations, and I'm going to substitute in 4. And I need to get true statements. 3 times 4 is 12. 12 is definitely less than or equal to 15. That is what we call a true statement. So I'll go ahead and I'll do the second equation. 9 times 4 got to be greater than or equal to 27. Well, 9 times 4 is 36. And 36 is definitely greater than or equal to 27. All right? So I know, or at least I have a really, really good indication that my solution is correct. All right? Are there any questions? All right? So the final way that we write our answer, and I'll write it in red, is we give our answer in interval notation. Now, if you've done this correctly and you checked yourself, the interval notation is staring you in the face. It's right there. In other words, bracket 3, comma 5 bracket. Does that make sense, everyone? Does that make sense, everyone? Okay? So this, like I said, this whole idea with the word and, all right, when you're combining statements or combining inequalities, the word and means intersection. You are looking for values of x that satisfy both. You are looking for that middle part right there in between the two sets. Okay? Let's look at another example now, because sometimes you don't get this nice, clean overlap like we have here where it's like what we call bounded, okay? Let's look at another example. See you, babe. Love you too. All right, so we're going to do x minus 7 is less than 2, and 2x plus 1 is less than 9. Okay, now, if you have colored pens, colored markers, colored highlighters, you don't even have to really draw all 3 separate lines. You could just do one. Let me show you what I mean by that. This only works, though, if you have different colors, okay? Otherwise, just stick to the first example that I did, which is drawing 3 of them and calling it a day. So we're going to approach this the same exact way. X minus 7 is less than 2. So I add 7 to both sides. I get X is less than 9. So because this is less than, I'm going to go ahead and use a parenthesis. I'm going to shade to the left. And you're going to notice here that I'm going to shade using a highlighter. And then I highlight the X is less than 9. So I know the yellow color means X is less than 9. Next, I will do 2x plus 1 is less than 9. So subtract 1 from both sides. Get out of the garbage, please. Thank you, sir. So I do 2x is less than 8. And then I will divide both sides by 2 to give me x is less than 4. And I will go ahead and use a different color. I'll use green. So I labeled my 4 on my number line appropriately. 4 definitely comes before 9. It's going to be another parenthesis. And it's also going to be shaded to the left. So there's my other parenthesis. And then I shade this to the left. Now remember, the and statement means it has to satisfy both. Okay? The only place that occurs is where I shaded green, because that's where you have yellow and green on top of each other. Okay? So, in set builder notation, I'm going to write x is such that x is less than 9 and x is less than 4. Okay? Which equals x is such that x is less than 4. And the reason I wrote that is because that shading overlap occurs from 4 and less, or values of x that are less than 4. So my interval notation, and I'll write that in red, is going to be negative infinity all the way up to 4, not including 4. Are there any questions there? So like I said, if you want to do, if you have the highlighters, go ahead and use that. If you don't, if you only have like a pencil or a pen, just write out 3 of them and then just mush them together and you'll be fine. Now, I want you to do this one. This one is going to make you think a little bit. Okay? It's going to make you think a little bit. So here's your example. 2x is greater than or equal to 0, and 4x minus 1 is less than or equal to negative 9. Does anybody need any help? Oh, look out. Look out. Okay. Are we good? Who got an answer? Who got an answer? I mean, just tell me what you came up with. Even if it's, well, I don't even know what I'm doing, Mr. Float. Fine. Remember, it's okay to be wrong. We are learning. You didn't get any overlapping. None whatsoever. Are you sure? Okay. Anybody else?
I didn't either.
Hey, you didn't get... Wait a minute. Did I write the problem down right? You're trying to tell me, Courtney, you didn't get...
I just wrote like no solution or something because I didn't know what to put.
So hold on one sec. So Courtney, you got no overlap. April, you got no overlap. And Courtney is showing us she's showing us her work. Did anybody else get no overlap? Carly got no overlap. So 3 people in the room have no overlap. Which means maybe we are actually on to something. What do you think? Well, let's do this problem. 2x is greater than 0. Divide both sides by 2. X is greater than or equal to 0. I'll do this the old school way. Bracket, shade to the right. Now the next one. 4x minus 1 is less than or equal to negative 9. So I I add 1 to both sides. That gives me 4x less than or equal to 8. Divide both sides by 4. X is less than or equal to 2. So directly underneath, I know 2 is going to be to the right of 0. It is negative 2. You are correct. Apparently, Mr. Float doesn't know negatives and positives yet. But this is going to be less than. And I shade to the left. Well, that's interesting. Or as people on TikTok would say, that's suspicious. I watch a lot of TikTok. It's bad.
Are you getting addicted to TikTok now?
Oh, you have no idea, Carly. You have no clue whatsoever. I might start my own TikTok page of me dancing. No? Maybe I'll just do math stuff. I'll do math stuff. I'll be like, hey, check out this math problem. Anyways, if we all got this solution that is on the board right now, which is correct. So Carly, April, Courtney, you're all correct. All right? And April, you said something very specific. You said you wrote something down. And what is that thing that you wrote down?
I wrote no solution.
And that's exactly the situation here. There is no solution to this problem because there are no values of x that satisfy both inequalities. It doesn't work. Now, you could write the words no solution, or you could write this symbol right here. It's a circle with a big slash through it. And what that stands for what we call the empty set. The empty set is like, think of an environment, or better yet, even simpler, think of a room where there is like nothing in the room. Nothing whatsoever. Okay? Do not think that a set with the number 0 inside, let me write that better again. Do not think that this is the empty set. That is false. That is a set where you have the object, which is a number 0. The empty set has nothing in it. It's like a void. Okay? Are there any questions? All right, well, good job on this one. Like I said, this one's going to make you think a little bit. But remember, you got to have faith in yourself. If you know you did it correctly, if you know dividing both sides by 2 is 0, and solving for the second one, you get x is less than or equal to 2, and you graphed it properly. If you feel confident with that, then you just roll with that. Just say, that's what it is. I don't know what it means yet. I'm sure Professor Float will tell me, but I know that's what it is. All right. Any questions? All right. Let's do 2 more things. All right. First one is what we call a double inequality. Now, a double inequality is exactly what it says. Double means 2, and inequalities mean inequality symbols. So you're going to have 2 inequality symbols together. So here's a really simple example of what it looks like. Okay? Artie, come here. Hi, buddy. So when we go ahead and look at this problem, I'm going to read it from left to right because I always read inequalities from left to right no matter what. I read this as 2 less than 4 plus x less than 7. Okay? And somebody help me out with finishing this statement. Artie, come here. I hate it when he goes behind the couch because he's always up to no good back there. So if I can at least see him, then I know what's happening. So here we go. 2 less than 4 plus x less than 7. Somebody finish the statement for me. Whatever you do to one side, you must do to the other. Thank you very much, Carly. So when we solve inequalities, we're just going to do this. We're going to say whatever you do to the middle, you must do to the left, you must do to the right. The directions are solve. My x is right in the middle. So in order for me to isolate the x, I need to subtract 4. But I subtract 4 from the middle, which means I subtract 4 from the left and subtract 4 from the right. Now, we'll go left to right. 2 minus 4 is negative 2, which is less than x, which is less than 7 minus 4 is 3. And you just solved your first double inequality. So now what we're going to do is we're going to graph it and write our answer in interval notation. What I like to do is come directly underneath, put my lines, and write negative 2 and 3 respectively. Okay? So from here, this is the way we need to think about this. The negative 2 and 3 are called endpoints. And they basically contain the x value. They bound the x. Okay? We use the word bound a lot in like calculus class. We have upper bounds and lower bounds, stuff like that. So think of the 2 and the 3 as the two numbers that x will not pass. So if that's the case, when you go to write, or when you go to graph, since they are less than, you're going to use parentheses, and you're going to write an open and close parentheses. Okay? And you shade in the middle. And if you could just do that correctly, the interval notation is staring you in the face. Parenthesis, -2, comma 3, parenthesis. All right, are there any questions? I mean, that's it. I think I really believe a lot of this stuff is like pretty straightforward. All right, I'm going to give you an example to do. This one's going to be a little bit more difficult, okay? So, let me give myself a little bit more space. So we're going to solve -1 is less than or equal to 2 times x divided by 3 plus 5, which is less than 2. So go ahead and do that one. Okay, anybody need any help? Anybody get an answer yet? All right, give you another minute. Courtney, you look stuck. Well, let's do this problem together then. You ready? We know we need to solve for x, and the x is in the middle. Do I see fractions, yes or no? So why not just multiply everything by 3? What would that do? Okay. So I'm going to multiply everything by 3. All right, so 3 times -1 is -3, which is less than or equal to. We know the 3's here reduce, so it's going to give me 2x plus 15, which is less than 6. So now I subtract 15 from everything. Negative 3 minus 15 is going to be negative 18, which is less than or equal to 2x, which is less than 6 minus 15 is going to be negative 9. And then I divide everything by 2. So negative 18 divided by 2 is negative 9, which is less than or equal to x, which is less than negative 9 over 2. Now, all I'm going to do is graph. I know that x is going to be contained inside negative 9 and negative 9 over 2. So all I got to do now is look at the inequalities, and they tell me what symbols I use. Since when I read this from left to right, I have negative 9 is less than or equal to. That gets a bracket. And the negative 9 over 2, the inequality right before that, is a less than symbol. So it gets a parenthesis. And I shade in between. And the interval notation is staring me in the face. Are there any questions there? Courtney, where did you get hung up on? What part?
So I subtracted 5 first, but I still ended up getting the negative 9 over 2, and that's where I was stuck, because I was like, I'm trying to get rid of fractions. So I was like, in my head, I was like,
sometimes you just have an answer that is a fraction. What's wrong with that? Nothing's wrong with that. So good job. All right. Now, this is the next example. I'm telling you right now, we have 3 examples left for today. This is the worst case scenario. Okay, this example right here. We're going to do a very similar problem. It's going to look the same, except instead of 4 plus x, I made it 4 minus x. This right here is going to come back to bite us, that negative symbol, okay? So once again, I would approach this the same way I do all of them. I'm going to subtract 4 from both sides. I'm going to solve for x. So that's going to give me negative 2, which is less than negative x, which is less than 3. All right? Now here is where that negative in front of the x comes back to haunt us. So I know I have to divide by the number in front. That number in front of the variable is a negative 1. So I divide by a negative 1, but here's the problem. Whenever I divide by a negative number using inequalities, the inequality symbol must change. So right now, this is going to be positive 2 greater than x greater than negative 3. But here's the issue with this. I'll give you a second to write it down because I want you to watch. All right, here's the problem with this. If I were to go directly into my number line, notice that is not true. 2 does not come before negative 3. Does that make sense, everyone? I mean, am I confusing anybody with that? All right. So what we have to do here is we need to take this result and you got to reverse it. In other words, what you're going to do, and I wish I had an object. Here you go. So right now, here's how it looks. I have this marker. This cap represents the 2. The end of the marker represents negative 3. What I need to do is flop it around. I need to just reverse it like that. So I'm going to write negative 3, x, and 2. And I'm going to take these inequality symbols, and I'm just going to make sure that they point to the numbers that they're supposed to be pointing to, the negative 3 and the x. So all I did was just I reversed it. So now it makes sense. Negative 3 is less than x, which is less than 2, which is a true statement. That is our worst case scenario, is when we have to divide by a negative number. Okay? Any questions? All right. So the last thing we're going to do today are statements containing the word or. Okay? So the word or, so or denotes a union between two sets. All right? So visually, if I use a Venn diagram, just like I did previously, I have sets A and B. Excuse me. And the union is going to be basically everything. Okay? Now, it's a little bit, visually, it looks easier than what it actually means. All right? So, oops, sorry. The word or means either or. So I'm going to put a little arrow. All right, so the word or means either or. And what this means, we are looking for values of x that satisfy either inequality or both inequalities. All right, so here's what's happening. And I think it's really good that we did the and statement first. Okay? With the and statement, we need to satisfy both inequalities at the same time. With the or statement says, listen, I don't care which inequality it satisfies as long as it satisfies one of them. Or you may run into the situation where it satisfies both, and that's okay as well. So if you think about it, the union will generally have, in fact, I want to be careful because it's been a long time since I've studied set theory, but unions have larger sets than intersections, because intersections have to satisfy both. Unions, it's either or. Okay? So let's look at a simple example here. And this is one that you would have seen before. We're going to graph x is less than or equal to 3, or x is, let's make this less than, make this 3 negative. So graph x is less than or equal to negative 3, or x is greater than 3. So here's my x is less than or equal to negative 3. That gets a bracket, and it goes to the left. Here is my x is greater than 3. So it gets a bracket, and it goes to the right. Now, if I look at the solution, then what I'm going to do is I'm going to take these two graphs. I'm going to mush them together. I'm just going to write one on top of each other. Now, since this is an or statement, remember, we're only concerned with satisfying at least one solution. So our set builder notation solution is going to be negative infinity to negative 3 with a bracket, union, bracket 3 to infinity. Does that make sense, everybody? Here is the major difference between this problem and that one and problem. In fact, let me zoom out. Let me go find that one real quick. You don't have to write this down. I just want you to look at it. All right. Here are the two problems right here. Notice if it's an or statement, you actually get a solution. Negative infinity to negative 3, including negative 3, or 3 to infinity, including 3. Like, you get a solution. If that compound inequality is the word and, you don't get a solution. Does that make sense? Does that make sense, everyone? Just at least give me a thumbs up or a yes. Okay, good. All right. Got a couple thumbs up in the crowd. Thank you very much. So here we go. Let's look at another answer now. Or another answer. Let's look at another problem, okay? So this one, we're going to do solve negative 2x, which is less than 5. Or sorry. Negative 2x minus 5 is less than negative 3. Or 6x is greater than 0. All right? So for the first, we're going to go ahead and solve it. I will add 5 to both sides. That gives me negative 2x is less than positive 2. Now I will divide both sides by negative 2 to give me x is greater than negative 1. Remember, divide by a negative number, reverse the inequality sign. All right, so there's my shading. Parenthesis at 1 opens to the right because I want values of x that are larger than negative 1. For the second inequality, that one's really simple. X has to be greater than 0. Oh, hold on one sec, everybody. I wrote the problem down incorrectly. I'll write in red what you need to change. I wrote the problem down incorrectly. You're going to let me... There you go. It has to be 6x is less than 0. That was my bad. I wrote it down incorrectly. Because I wanted something to happen here, and when I noticed it wouldn't happen, I got a little scared. But then I fixed it. Now I'm not scared anymore. So, x is less than 0. Gets a parenthesis. We shade to the left. Now, if I were to combine these two together, notice that no matter what I shade, everything just overlaps. Okay, now remember, this is an or statement. Or you got to satisfy at least one or the other or both. So with the overlap here, I satisfy both of these equations at the same time. Doesn't matter what number or which one I pick. Excuse me. So my solution, or my interval notation, is going to be negative infinity to positive infinity. All right? Which is all real numbers. Okay? Are there any questions there? So, real quick, today we went over compound inequalities. The and statement is the intersection. We are looking for values of x that satisfy both equations. Then we looked at double inequalities, and the only hiccup that you can run into is if you have to divide by a negative number. The last thing we looked at was the or statement. The or statement, we are looking for values of x that satisfy at least one of the inequalities. It could satisfy the first or the second or both of them, doesn't matter. Always write your answer in interval notation. And do you have any questions for me?